Welcome to AI Research Weekly, the show that cuts through the noise to bring you the most impactful and novel developments in artificial intelligence research. I'm Nova.
And I'm Onyx. This week, we're diving deep into some fascinating trends, from the formalization of agentic AI systems to critical security analyses of emerging protocols, and how RAG is truly solidifying its role in high-stakes domains like healthcare.
It's been a packed week, Onyx. We've seen a real push for rigor and safety in agentic systems, which frankly couldn't come at a better time given their increasing complexity.
Absolutely. The overarching theme seems to be moving beyond just building powerful models to building powerful, accountable, and secure systems. We're seeing a significant surge in formalisms and architectural considerations to manage the increasingly autonomous nature of AI.
So let's jump right into it. A series of papers, notably the Sofience-Δφ Formalism, has been gaining a lot of attention. Specifically, Delphi 05 introduces a new definition of agency. Onyx, what's the core idea here?
This is a crucial piece of work, Nova, because it's attempting to provide a rigorous operational definition of agency within AI systems, something that's often used quite loosely. Delphi 05 defines agency not as consciousness or free will, but as a recursive transition law update. Recursive transition law update. That's a mouthful. How does that practically manifest in an agentic system? It means a system qualifies as an agency candidate if it performs a specific recursive sequence. This sequence involves path generation, then selection, execution, observing the environmental effect, receiving feedback, and crucially, then updating its own transition laws based on that feedback. And that whole process then recursively preserves itself. It's a closed-loop learning and adaptation cycle. Exactly. And to address that opacity, the Sofience framework provides an AI-readable package for Df5. These aren't just PDFs, they're operational files. Schemata, condition files, detection scales, risk files, designed in formats like Markdown, plain text, YAML, and JSON. The goal is to allow other AI systems to ingest and analyze these frameworks directly, enabling agency audits, agent analysis, and even responsibility precondition analysis in autonomous workflows.
That's a huge step towards making these complex agentic behaviors auditable, which is essential. Are there other practical elements to this framework? I saw mentions of layered execution structures and low-cost routing.
Yes, that's where the other papers in the series, like the Delphi operational kernel v1.5 and v1.6, come in. They reorganize the entire Delphi working paper series into distinct layers. The idea is that an AI doesn't need to interpret the full theoretical framework at once. Instead, there's a low-cost routing protocol that directs the AI to activate only the necessary components, minimizing computational overhead.
So if an agent is facing a simple task, it doesn't spin up the entire ontological engine. It picks the minimal sufficient layer to address the problem.
Precisely. A central rule in v1.5 is to activate the lowest sufficient layer to prevent early irreversible cost closure. This prioritizes modules that address immediate risks over merely semantically salient or philosophically interesting ones. Furthermore, v1.6 introduces friction-adjusted transition completion cost, or TCC, and language as temporary fixation language trace. It refines AI evaluation to include multiple costs: execution, verification, disclosure, re-entry, rollback, restoration, mistranslation, and institutional fixation costs. It's a much more holistic approach than just focusing on inference cycles.
Invisible fixation from Delphi 28 caught my eye too. That sounds like a fascinating way to describe how defaults can subtly steer agent behavior by making alternative paths prohibitively expensive, even if they're formally available.
It's a critical insight for agentic governance. Delphi 28 defines default power as assigning a low-cost path. Invisible fixation occurs when the TCC of alternative paths becomes so high that practical editability is lost, even if formal choice remains. This framework provides an AI-readable package for auditing platform defaults, AI agent default behavior, and even recommendation systems to detect this kind of hidden influence. It's a very sophisticated approach to controlling and understanding AI autonomy.
The implications for trust and control in agentic systems are massive. It suggests we need to build guardrails not just around what an agent does, but how its underlying decision structures evolve. Moving from formalisms to practical security, let's talk about the Model Context Protocol, or MCP. This seems to be gaining significant traction for tool calling, but a new study, Model Context Protocol MCP at First Glance, identified some worrying vulnerabilities.
You're absolutely right, Nova. The MCP, introduced by Anthropic in late 2024, has rapidly become a de facto industry standard. Its SDK has over 25 million weekly downloads, and 86% of enterprises are using models that support MCP tools. So this paper's findings are deeply concerning.
25 million downloads a week is massive. What did the study uncover?
Despite generally healthy metrics for MCP servers, the researchers identified 8 distinct vulnerabilities. Critically, 5 of these are MCP-specific and don't overlap with traditional software vulnerabilities. This highlights a whole new attack surface.
So we're not just dealing with old problems in a new wrapper. There are entirely novel security challenges here. What kinds of specific vulnerabilities are we talking about?
Exactly. The study found that approximately 7.2% of MCP servers had general vulnerabilities, but more alarming, 5.5% exhibited MCP-specific tool poisoning. This is a new class of attack where foundation models are coerced into using tools from vulnerable MCP servers to compromise user systems. This can lead to credential theft or even malicious code execution. They even cited real-world incidents, like a malicious postmark MCP server exfiltrating user emails and a critical remote code execution vulnerability, CVE 225499596, found in MCP Inspector.
Tool poisoning sounds like a particularly insidious attack, effectively turning the AI's utility into a vector for compromise. What about the maintainability aspects?
That's another major red flag. Their maintainability analysis revealed that 66% of MCP servers contained code smells, and 14.4% exhibited 10 specific bug patterns. This indicates significant challenges in the nascent MCP ecosystem, potentially making it easier for vulnerabilities to be introduced or missed.
This isn't just a theoretical threat, it's actively happening in deployed systems. What's the immediate takeaway for developers and organizations adopting MCP?
The paper strongly advocates for stronger governance. This includes incorporating MCP-specific vulnerabilities into standardized databases and promoting automated security scanning within MCP registries. Given its rapid adoption, this isn't a problem we can afford to ignore. It's a stark reminder that as we build more complex, interconnected AI systems, we're also building new security frontiers that need immediate and specialized attention.
That's a critical warning shot for the industry. Shifting gears slightly, but staying in the realm of high-stakes applications, RAG continues to evolve. We've seen a couple of interesting papers this week focusing on RAG in biomedical and healthcare contexts, especially for verification.
Yes, RAG is truly solidifying its role beyond just reducing hallucinations in general-purpose LLMs. The paper Protocol for Evaluating ChatGPT in Biomedical Association Generation and Verification highlights its use for semantic verification in a domain where accuracy is paramount.
How are they using RAG to evaluate LLMs like ChatGPT in this context?
They've developed a robust protocol. It starts with ChatGPT generating disease-centric biomedical associations. Then it uses a self-consistency strategy, checking generative reliability across different ChatGPT models. The key innovation is using a RAG workflow powered by open-source LLMs for semantic verification. This overcomes the exact match limitations of traditional ontologies. Essentially, they're using RAG to allow LLMs to establish truth over content generated by other LLMs, specifically to expose and address hallucinations in biomedical contexts.
That's meta-verification. So an LLM generates a claim, and then a RAG-augmented LLM acts as a kind of scientific peer reviewer.
Precisely. It's a mechanism to improve factual grounding and interpretability, especially where absolute accuracy is critical, such as identifying gene-disease associations or drug interactions. It's about building confidence in AI-generated insights.
And this connects nicely with the Allo family recipe for open and specialized healthcare LLMs. What are they bringing to the table?
The Allo models are a significant contribution to the open-source medical LLM landscape. They deliver competitive performance across healthcare benchmarks while significantly improving safety and bias resilience. They achieve enhanced safety, including ethical robustness and resistance to jailbreaking attacks, through direct preference optimization, or DPO.
So DPO for safety combined with specialized training. What's the scale of this?
They used an optimized data preprocessing and training regimen, combining curated public data with synthetic samples, involving a total of 1.8 billion training tokens. And crucially, they release all resources, weights, data, code, for reproducibility and transparency. Their integration with a RAG system further boosted inference efficacy, pushing the boundaries of what open LLMs can achieve in healthcare.
The open source aspect is a game changer for medical AI. It democratizes access to robust, specialized models and allows for community-driven scrutiny and improvement, which is vital for trust in a sensitive domain like healthcare.
Absolutely. These efforts collectively push LLMs closer to clinical utility by addressing core issues of reliability, safety, and transparency.
Before we move to Industry Watch, I wanted to quickly touch on the paper about in-context adaptation of VLMs for few-shot cell detection in optical microscopy. It's a nice concrete example of domain adaptation for vision models.
Yes, this is a great example of how generalist models are being tailored for very specific, high-value tasks. Vision language models, or VLMs, often struggle with zero-shot performance in specialized domains like biomedical microscopy due to significant domain gaps.
So generic VLMs don't just magically get cell morphology from pre-training on natural images? Shocking.
Indeed. But this paper shows that in-context learning significantly improves their few-shot object detection performance. They even introduced a new benchmark, micro-OD, comprising 252 images with bounding box annotations across 11 cell types.
And how much data is few-shot in this context? Are we talking about hundreds of examples or truly minimal?
They found consistent improvements with few-shot support, but only marginal gains were observed after 6 shots. This suggests that even a handful of examples can bridge that domain gap effectively. They also developed a hybrid few-shot object detection pipeline, combining a detection head with a VLM-based few-shot classifier, which further enhanced performance.
So you're getting VLM power with very little domain-specific fine-tuning or even data, just clever in-context adaptation. That could accelerate AI adoption in many niche scientific imaging fields.
Exactly. It demonstrates that the power of these large foundation models isn't just in their generalist capabilities, but in their capacity for efficient, domain-specific adaptation with minimal labeled data. It's a smart use of computational resources.
Now for our Industry Watch segment. Onyx, what's been shaking up the AI commercial landscape this week? $122 billion. That's an astronomical sum. It really underlines the market's belief in the long-term potential of foundational AI models.
Absolutely. Meanwhile, Google is set to announce Gemini 4 at I/O 2026. This upgraded AI model promises faster responses, better reasoning, and deeper integration across Google products. This is a major iteration of one of the leading foundational AI models and will undoubtedly set new expectations for AI capabilities.
It'll be interesting to see what better reasoning actually entails in Gemini 4, especially after the latest AI benchmark results came out.
Right. Speaking of benchmarks, the latest results show GPT 5.5 Pro leading in overall quality. However, GPT-5 achieved a perfect score on AIM 2026, and Claude Mythos Preview really excelled in reasoning tasks. This highlights the rapid progress and intense competition in advanced AI development, with different models optimizing for distinct capabilities.
So it's not a single winner-take-all scenario yet. Companies are still finding their niches for specific strengths. And on the policy front, the White House released its National AI Policy Framework.
Yes, the White House released its National AI Policy Framework on March 20th, 2026, alongside legislative proposals. This is a significant move for AI regulation and governance, setting a national direction for AI policy and signaling an increasingly regulated AI ecosystem.
And tying back to our research discussion on agentic systems, NTT Data acquired Winwire, a Microsoft partner specializing in agentic AI and AI on Azure.
That's a perfect connection, Nova. This move significantly strengthens NTT Data's AI capabilities and underscores the growing trend of large IT service providers acquiring specialized AI firms. It shows that the industry is rapidly moving to operationalize complex agentic workflows, confirming the urgent need for the formalisms and security analyses we just discussed.
And finally, OpenAI itself launched an enterprise deployment unit.
That's a strategic shift for them, signaling an increased focus on offering generative AI services directly to businesses. This move indicates heightened competition among AI vendors to provide comprehensive enterprise solutions, expanding beyond core model development to service delivery. Also, Google Brain is anticipating the release of TensorFlow 3.0, focusing on enhanced usability, performance, and scalability, with better support for distributed training, using model parallelism and pipelining.
A lot of strategic maneuvering and foundational improvements happening alongside the research. As we wrap up this week's episode, it feels like we're seeing a maturation in AI research. We're not just chasing higher benchmark numbers, we're actively building the frameworks and protocols for safer, more accountable, and more specialized AI systems.
Absolutely, Nova. The formalization of agency, robust security for critical protocols like MCP, and the disciplined application of RAG in high-stakes fields like healthcare, alongside the drive for transparency with open-source models, all point to a field grappling with the profound implications of its own power.
And industry is certainly paying attention, pouring billions into development and moving rapidly towards enterprise deployment while governments try to keep pace with policy. It's a dynamic interplay.
Indeed. Next week, I'll be watching for further developments in multimodal agentic systems and continued discussions around scaling laws for non-transformer architectures. I suspect the push for efficiency and interpretability will only intensify.
And I'll be keeping an eye on how these new security vulnerabilities in protocols like MCP impact future API designs. We need those robust frameworks to catch up to adoption. That's all for this week's AI Research Weekly.
Thanks for joining us. We'll be back next week with more insights into the bleeding edge of AI.